Hello there. I'm going to do today a small video related to the Heathkit Sierra Bravo 650 frequency display and how I use it in, well, I'm trying to use it in the SAC to make it usable. The difference from a frequency display to a frequency counter is that the frequency counter counts directly the frequency out of a signal generator or any other device that generates a frequency. But the frequency display actually displays the frequency after it is calculated from different sets of frequencies input to this particular display. So this particular frequency display, what it does, what it does actually is it has three inputs. It has the HFO input, the BFO input, and the LMO input. And basically the LMO is the VFO of a transceiver that you want to monitor. The BFO is obviously the BFO of the transceiver, and the HFO is the high frequency heterodyne oscillator that is used in particularly in those old transceivers to switch between different bands. So you basically had the VFO, which would operate at a fixed range of half or 1 megahertz or so, and a VFO, okay? And then you have your HFO, which was the mixing oscillator, switched mixed oscillator to cover the different bands, and then you have your BFO on receive to finely tune the receiver. So this particular Heathkit Sierra Bravo 650 takes care of all of these signals, and it does it heterodynes these signals inside, and it displays the actual frequency. Now the problem is that this frequency display has been designed so that it is compatible with Heathkit transceivers only. So you basically had to do a few modifications on those transceivers and take samples of the signals out of the VFO, the BFO, and the HFO. And I want to use it with a non-Heathkit transceiver. Actually, I want to use it with a Kilo Whiskey Mike 2A from Collins. So I don't want to really modify this transceiver and drill holes or output cables or do different nasty things inside there just to get these signals. So I thought I'm gonna use this Heathkit Sierra Bravo 650 to do a frequency checking, just a frequency checking of the transmitter. And since the transmitter and the receiver of this Collins transceiver are on the same frequency, and I have verified that they are on the same frequency, then the transmitter frequency displayed here will be the same as the receiver frequency. So basically, when I have the dial switched to a particular frequency, I should be able to see this frequency here. But notice that we no longer are going to use this frequency display for receive, but only for transmit. And the reason we're doing this is right at the back of the transceiver. If you see, I have connected to the HFO input a piece of cable, and this cable really goes to one of those split cores that you can buy very cheaply. Okay, it's just two pieces of ferrite material, and you clip it just push it to clip it and create a single toroidal core inside. So I'm using this kind of core because I'm going to monitor the actual transmitter output with this core. Okay, so basically what I'm doing is the actual core that I have right now installed somewhere around there back in the transceiver in the big bunch of cables, and I cannot find it now, so I cannot show it to you now, but the actual thing that I made is about 60 to 90 turns, if I remember correctly. It's about 70, 75, something like that. It depends on the kind of power you want to monitor with this. And I just wound these turns in one side of the core, and then I passed in the coaxial cable. The coaxial cable, my cable is RG223. So I passed it inside here, and I just clipped the core like so. It's a little bit hard to do. Yes, like so. And then the two let me put this here. The two wires out of the big loop of enameled coil wire that I have wound inside this core go to a set of anti-parallel diodes. So basically you have one piece of wire and the other piece of wire here, and then you have a diode that way facing down, and then right next to it a diode facing up, and you connect these two diodes with one piece of the enameled wire, and you connect them at the other side together and with the other piece of the enameled wire. And these two outputs that you will have here go directly to a small piece of coaxial cable, and they go directly to the HFO input of this particular counter. So what I'm going to do now is I'm going to show you how I use this particular setup, and then we're going to do together a bit of alignment to the frequency display to ensure that the right frequency is displayed. Okay, it needs a little bit of tuning if you use it that way. So what I'm doing basically is here in the transceiver I set the power to quite low levels, and then I just use the tune button in the transceiver to transmit a carrier tone, so that hopefully the frequency display will display the right frequency in this carrier tone. So here I go, tune. The power is very low milliamps, and you see here it says 5.198 and 800 hertz. So it's obviously it has only a 100 hertz resolution that way. Okay, so I switch off the transmitter, and then I switch back on the transmitter. Again, the same frequency. Okay, and you don't have to increase the power quite a lot here. If you see the Mach gain, which sets the output power on the tune also, it's really low, a little bit lower than the third marking actually. So it only draws now what is it, 50, 60, 70 milliamps. Okay, the power amplifier draws 70 milliamps just to be able to display a stable frequency here. Of course you can go to higher powers here, and there's no problem with this setup. You can easily go to higher powers, but there's no need to push the limits on the transmitter here, okay, to hit the tubes too much. You can use just a very low power here. And notice, let's demonstrate that. As I tune the frequency here, now we are in very low power, I can tune the frequency Let's go directly to 200. Okay, I can tune directly. I can see the frequency directly here. Now there's a slight problem with this technique, and the problem is basically that you're using the actual tune button to do everything, and you're using actually a carrier here, which is stable and can be stably monitored in this counter, in this frequency display. So obviously you can't do it with SSB when talking or even when whistling, because you're going to change the actual frequency. Actually you're transmitting your voice, so your voice fluctuates in different frequencies, and it has different amplitudes, and you can't actually monitor the transmitter frequency that way using SSB voice. You have to use a stable carrier here. So here you go, you use the stable carrier, and then you have the exact frequency here. The problem is that the tune button here in this transceiver actually has a little bit of offset. Okay, the carrier has offset from let's say the 0 frequency here in the lower sideband. Has a little bit of offset, but thankfully the offset is stable and the same at all bands. So all we have to do to make this thing work is and show us the actual frequency is to set this button to the tune position, and then monitor the frequency here in the frequency display. And when we set the button again to the LSB, to the lower sideband position, and try to talk on the transceiver and monitor this frequency on another modern transceiver nearby, these two frequencies, the tune frequency and the LSB frequency, must be the same. What I'm talking about is that, for example, if you are at 7.2 megahertz and you're talking LSB, and then you have you monitor this with a modern transceiver, okay, you know that you are on 7.2 megahertz, okay, here for example, and then when you tune, when you switch to the carrier, it will offset a little bit the frequency of the carrier, okay, and this offset will be shown here in the frequency display. Now we have to tune the frequency display inside from the internal circuits, so that this frequency actually represents the frequency that is shown on the SSB transceiver when operating on SSB voice. And that's a trick basically. We misalign, we tune a little bit off the frequency display, so that on the tune position it shows us the actual carrier frequency, which will be the same as when we switch to the LSB position, okay? That's a trick here. To demonstrate that, I have set this transceiver here to transmit, and I have set this transceiver here to receive just by leakage, okay? And then I transmit here 1 2 3 4 5 1 2 3 4 5. Now I know that I'm exactly on the frequency on SSB, so when I switch now to the tune button, the counter here should show 7.2 megahertz, okay? If it doesn't show 7.2 megahertz, and notice that as I speak the frequency changes, which is very typical, okay? I'm changing the frequency on my voice on SSB when I'm talking. So let's try the tune.